get, it says here, points A, B, and C are on this. What kind of a graph is this?
That's a hyperbola.
Yes, it's a hyperbola, even though the format is just scrambled. It's still a hyperbola because this is the format of a hyperbola. They gave us 3 coordinates. Then they say write down the values of A. Wait, what? Write down the value of this expression. Oh, this is just 3 things being multiplied together. So we need to get the number A, the number P, the number Q, and then we just need to multiply them all together. I don't know why they put a dot here, but that makes things a bit awkward. But yeah, this kind of a question, it looks as though we just need to get all those numbers, A, P, and Q. Once we get them, we need to multiply them together. So one thing we can keep in mind is that if we're going to get A, P, and Q, and this is a hyperbola, the coordinates that they gave us, obviously they need to help us some way, somehow. So the fortunate thing is, in these 2 coordinates, 2 of them have 0 as one of the coordinates. So you can see here, this is a y-intercept.
Intercepts.
Yeah, one is a y-intercept, one is an x-intercept, because for one of them x is 0, for the other one y is 0. So here, because x is 0, this is a y-intercept. And then for the other one here, y is 0. So this is an x-intercept. Does that make sense?
Yes.
Yeah. So since we now know all this information, right? Let's see what we can do. Let's see what can make our life easy. Because if you were to work out, if you were to put in a y-intercept, right, you make x a 0 there, you end up with like a weird equation. If you get the x-intercept, you make y a 0, you end up with a weird equation. The only annoying thing with this kind of equation is that we have 3 unknowns, and having 3 unknowns makes things a bit weird for us. It really does. But what I would also then do is try and figure out what kind of a shape this looks like, because if you figure out what kind of a shape this looks like, it can help a bit. Because remember, hyperbola has 2 asymptotes. So let's just see what these coordinates will give us. This is 1 coordinate 0. So x value is 1, y value is 0. So that's like somewhere there. And then this one here, b, right? X value is a 0, y is a quarter. That's like somewhere there. And this one, x value is a 3. Let's see here. I did what? 1, 2, 3. So let's say 2, 3. X value is a 3, y value is a negative 2. So that's like somewhere there. So this is kind of weird, but you'd be wondering, do these 3 points all join each other to make one dot, or is it like multiple? You really do not know. And yeah, this is the kinds of things that make life slightly more difficult than we would want it to be. So we do have to think creatively. Otherwise, yo, is gonna be in trouble. We're gonna be in trouble. But the one thing I can safely say is it's very rare for a hyperbola to have an x-intercept and a y-intercept separate from the same curve. Because remember, a hyperbola has 2 curves, right? So normally the x-intercept and the y-intercept will normally be on the same curve. Just normally, but not all the time. But making assumptions is not very helpful. So for this kind of a question, we need some kind of a system. So I'll just do the one thing that I'm avoiding, which is just, for example, throwing in some coordinates in here, trying to work it out simultaneously and all that, So yeah, let's maybe start with that. Let's see, if you throw in one of your coordinates, let's put A in this equation. So y value is a 0, x value is a 1. So you can have 1 minus 2. I mean, if push comes to shove, let's put if you take this whole thing here to the left, you're gonna have negative a over 1 minus 2, like this. This is equal to q. This does not look like it's gonna help at all, because the only thing with 3 variables is very likely that we'll find ourselves going in circles if we try to just throw in a coordinate, see what we end up with. But let's just carry on. Let's not give up too soon. Let's
Okay.
put B. Let's put B. So if you put B in our equation, we're gonna have Y is equal to is equal to what? No. Putting B means Y is a quarter. So this is like a quarter equal to Q, and then plus A over what's the X value now? The X value is let me just move this thing here. This is A, right? The X value is 0. So this is 0 minus what? P.
Whether we want to use simultaneous equation.
That's what we're going to find out. We just want to see what we end up with here. So this is going to be a quarter, right? This whole thing goes to the other side. It's going to be a plus A over Q. No, A over P. So you have two equations here that are both equal to Q. So let's just see what they give us if we make, yeah?
Well, I'm saying I got the two equations. I did simultaneous equations.
Okay, let's see what's going to happen if we make them equal to each other. So here we can say negative A over 1 minus P equal to a quarter plus A over P here. So yeah, this is an equation that has A and P in it. Let's try and see if we can get another equation that has A and P in it. We probably will if you throw in this third coordinate into this equation, right? So where Y is, we're gonna put a negative 2 there. So it's gonna be negative 2, excuse me. And then X is a 3. That's like Q here. X is a 3, right? So that's like plus A. This is like X is a 3, right? So it's like 3 plus 2 there. And then if you isolate Q as we have been doing, it's going to be negative 2 here. And then negative A, no. Negative 2 minus A over 3 plus 2 is a 5, right? So this we can make it equation number 3. Now we can make equation number 3 equal to one of these two. Let's choose the very first one since it has no fractions. So here we can say negative A over 1 minus P equal to this one is minus 2 minus A over 5. Wait, what? Something does not seem right here. Where did I get the 2?
No, I have the same question. Why are you putting two there?
Yeah, I'm actually wondering myself. And I'm like, bro, nope, that's wrong, man. I don't know where I got the 2. It's supposed to be negative 2 there. Negative 2. Okay, there we go. Then if you take everything on one side except for Q, you end up with negative 2 minus A over 3 minus P equal to Q. And then this thing here, right, you're going to make it equal to any one of the first two. So let's do that. So let's do it. And then the negative 2 minus A. Let's make this equal to the first one, right? Minus A, 1 minus P, like that. Yeah. Now let's solve for A and P simultaneous because we have this, we can make this equation number 4. Technically this, we can look at it as equation number 5. So, okay, yeah, it's going down. So here, if we're gonna solve for A and P, we can isolate. What can we isolate here? Yeah, it looks serious. It looks very serious. I think we might as well have used this one. This one looks, it looks like it's easier to work with. This equation here. So let's use that one instead. So let's do a quarter plus A over 2. So when you get an LCD, you don't have to get an LCD for everything. You can actually just do one for one side. And then once they're both fractions, you can just cross multiply. So here you can just multiply by 4 over 4. You can just multiply by P over P. So you can have P plus 4A over 4P. You understand what we did on the left-hand side?
Yeah.
Yeah. And then we're going to cross multiply now, since the fraction and the fraction. This times that, going to give you negative 4P with a plus. Now you're going to pay there. And then this times that. So the one thing I'm actually trying to do here is we need to isolate one variable, either A or P, so we can work them out simultaneously. But then the more we do whatever we're doing now, the more everything just seems to be getting all cramped up, getting all, I don't know, it's just going all over the place, and it's reminding me of how from the beginning, we're just like, what, three coordinates and having to figure out three values. It doesn't look like it's really working out well. Doesn't look like it's working out well for us. And I do suggest maybe we even move on to another question. Because, I mean, if this is not working out now, we could spend time trying to figure out, and we probably will, but I think for the sake of time, might as well just move on. And you might as well also do that tomorrow also, when you'll be writing your what you call your Olympiad. Because what I can say is anything that's gonna look like a wild cut question, anything that you see may just be dragging, and it does not look like there's hope in the time we have. The best you can do is move on. Whenever you're done with the full paper, you can always come back. So, we might as well practice what I'm preaching right now.